Okay, welcome. It is Tuesday night, May 4th, and may the 4th be with you. This is Michelle Carter from the Aram Public Library, and tonight we are so pleased to welcome author Scott Spoolman, who will be sharing his geological and state park adventures with his book, Wisconsin State Parks. If you missed it, he'll be taking questions at the end, so feel free to put your questions in the chat window or just to hang on to them and he'll get to them at the end. Take it away, Scott.
Thank you, Michelle. And thanks to those of you who have come to see. Thanks for inviting me to present my book, Wisconsin State Parks, Extraordinary Stories of Geology and Natural History, published by the Wisconsin Historical Society Press. I'm sorry that we can't visit in person. I always enjoy going to libraries and presenting in person. And I would enjoy visiting the Delavan area with its beautiful lakes and colorful history. Well, maybe someday we'll do the best we can online. In the meantime, the process of researching, writing, and publishing this book took me about 4 years. Along the way, I got tremendous support from my wife, Gail, in the form of help with ideas and research, coaching, and managing. And she's here with us tonight. She's in the listening in here. Also, just a bit of bragging, just a little bit of bragging here. This book was the 2018 bestseller for the press, and it won a gold medal in a national book competition in the category of regional nonfiction. So it's been a lot of fun. In a little while, I'll walk us through a virtual tour of one of the state parks covered in my book, and we can follow that with questions, as Michelle mentioned. Feel free to enter them in the chat if you wish. And we'll also take a little side trip to right here in the Delavan area to look at the geologic story of this area. This is something I enjoy doing. Wherever I go, I like to research and talk about the local geology, just briefly. People often ask how I got started on this project. It really started when I was very young. I grew up in the northwestern part of the state. I was lucky to have parents who got my brothers and sister and me into the woods very often to explore. And I remember one day in particular on a trail in the woods south of Ashland, Wisconsin, we were hiking along and rounded one bend on the trail, and there was gorgeous little Morgan Falls. This is a secluded waterfall deep in the woods, deep in the North Woods, and it was the first waterfall I ever saw. So I dedicated the book to my parents because it was experiences like this that sparked my desire to know the history and the geology of such places. And Gail and I have carried on the tradition, taking our kids to the places we enjoy, and that's Devil's Lake in the background there. Since this photo was taken, we've all grown some. These experiences have helped to shape my career as a science writer. Now, one thing that caught my eye a few years ago was this beautiful map published by the Wisconsin Geological and Natural History Survey. In fact, I have a copy of it mounted on my wall in back of me. It does a good job of showing the variety of landscapes in our state, including the deep north woods of northern Wisconsin. Deep woods of northern Wisconsin, the cliffs on the east side of the state in Door County, the central sand plain with its buttes and spires of sandstone, the mounds of sandstone, and the driftless area of the southwest with its deep valleys and river bluffs. That's Gail in the photo there. She's checking out a feature at her favorite state park, which is Wyalusing State Park, and this is called the Keyhole. So it occurred to me that to zoom in on any one of these areas and to explore them, one could use the wonderful state parks as entry points. And we can think of the parks and the state forests as time portals or gateways to the ancient past. And that idea really intrigued me. I decided that by going to the parks, exploring, learning their stories, and maybe telling them in a book, I could share my fascination about the geology and natural history of our state. So that's what I did. And my hope in writing this book was to provide a guide that you might use to understand and enjoy our wonderful state parks. We'll visit Devil's Lake State Park here in a few minutes. But first, let's talk about some key concepts that will help you to fully appreciate the Devil's Lake story and all the other stories in the book. These key concepts are covered in chapter 1 of my book. And the first one is the immense time scale covered in the book. I ask you to take yourselves out of our daily time frame that we divide into hours and minutes and seconds, and to try to shift into the much larger frame measured in centuries and millennia, millions and billions of years. And there are 5 spans of time that I'd like to focus on very briefly here to set the stage. First is the Precambrian era, the first 4 billion of the entire 4.5 billion year history of the Earth. It involved continental collisions that formed ancient North America, and in what would become Wisconsin, it included mountain building. Next is the 50 million year Cambrian period, a time when ancient seas invaded our area and life began to evolve in those seas. During the third period, the roughly 135 million years following the Cambrian, more ancient seas invaded, and the evolution of sea creatures and plants in those oceans accelerated. And then during the next roughly 400 million years, the last of those seas had departed and erosion took over and wiped out the fossil record for all of that time, especially in Wisconsin. So for example, we don't really know if dinosaurs ever actually did roam in our state during the famous Jurassic period. They probably did, but we don't have any proof of it because the fossil record is gone thanks to erosion. And finally, the 2.5 million year ice age, the Quaternary period it's called, the time of the glaciers, and within the last 200,000 years, the emergence of modern humans. Another key idea for understanding the park stories is the fact that for much of its history, the Wisconsin region was tropical. I want to thank the UW Press for the use of this image, which David Michelson and his co-authors used in their great book, The Geology of the Ice Age National Scenic Trail. Early in its history, the crust of the Earth was fractured into several large pieces called plates. And they were jostled and moved around on the planet, driven by the intense heat of the Earth's interior. This process is called plate tectonics. And the plate on which Wisconsin rode, called the North American Plate, in Precambrian time was south of the equator, right here. And due to plate tectonics, it took kind of a curlicue path as it moved around, being bumped and jostled by the other plates. It crossed the equator heading north about 350 million years ago, kept moving, shifting, moving, landed in its current position about 10 million years ago. And we are still moving, by the way. The North American Plate is shifting southwest, roughly southwest, about as fast as our fingernails are growing. Beyond chapter 1, my book is organized geographically among 5 regions with a chapter for each region. Now, each of Wisconsin's 49 state parks and 10 state forests have a great story to tell. But for each region, I picked the 5 or 6 stories that best represent the dramatic processes that had occurred there. Let's take a quick tour of the regions. In the Northwest corner of the state, Copper Falls State Park is largely the result of volcanic activity. That's Brownstone Falls in that park, and that's volcanic rock all around and under that falls. In the northeast corner of the state lie the parks that lie on sediments of ancient seas that were converted to hard rock and later unearthed by glaciers and other processes, forming features like these cliffs that make Door County famous, this one at Peninsula State Park. And here in the rolling countryside of southeastern Wisconsin, the glaciers molded the landforms, including this cone-shaped hill or came up at, it's called Dundee Mountain up at Kettle Moraine State Forest. I'm sure some of you might be familiar with that. here in this, or in the south central region of the state, the glaciers molded, several processes, including the glaciers, molded the landforms. A bit later, we'll get into the story of how such processes shaped features like the balanced rock at Devil's Lake State Park. And finally, in the southwest corner of the state, the driftless area, never invaded by glaciers. The slow, steady process of erosion formed features such as Eni Point at Governor Dodge State Park. This is a sandstone mass sculpted by wind and water erosion uninterrupted for hundreds of millions of years. And that's my son Will in the photo there. He was helping me out with photos that day. Each park story has an introduction with more details on geology and natural history. In many cases, I also include some early human history explaining how Native Americans lived in the park areas and why they too regarded them as special or even sacred. For example, this is Trempealeau Mountain up at Perot State Park on the Mississippi River. It's long been regarded as sacred ground by the Ho-Chunk people, and the access to it is partly restricted in honor of that. Each story includes photos like some of those you're seeing here, and I took all but a couple of photos in the book on my hikes in the parks. And also each story is followed by one or more trail guides that I wrote up after hiking those trails. They preview what you'll see on each trail, such as rock types and formations and how things have changed over time. You can think of one of these trail guides as one of those recordings that you can listen to when you walk through a museum or a historic site. So the idea is to take the book with you to the park, pick up a trail map, hit the trail, and play geologist. So let's do that now. We'll go on a virtual hike through Devil's Lake State Park. We'll be walking through one of those time portals that I mentioned a little earlier. Devil's Lake, as you probably know, is 100 miles northwest of the Delavan area. It's one of Wisconsin's oldest state parks, established in 1911. And this feature here is called the Devil's Doorway. Kind of looks like an ancient gateway, I think. What we'll see as we go on our hike is a progression of extraordinary processes, including continental collisions with mountain building, invasions by ancient seas that brought destructive storms, old rivers flowing and eroding rock for millions of years, crushing glaciers, and finally, centuries of quiet erosion by wind and water. Excuse me. Devil's Lake lies in a wide L-shaped gorge that stretches down from the north or toward us in this photo, and then takes a 90-degree turn to the east. And it's within the north-south portion of the park that Devil's Lake lies. A passage from my book sets the stage for the story of Devil's Lake. It describes a view from up on one of the park bluffs. And the following paragraph tells how this scene has changed over time. If you could turn back the clock about 2 million years, the rocky cliffs and forests around you would look much the same, but the scene below would be strikingly different. Instead of gazing at a placid lake 500 feet below, you would be looking down 800 feet at a river flowing in the bottom of a V-shaped gorge. The valley would be wide open, not blocked at either end by land masses as it is now. The stream would be sweeping down from the north, swinging lazily around the bend below you and flowing east out of the gorge. But we'd have to go back much farther, turn the clock back much farther to get to the beginning of the story. Let's go back about 1.7 billion years with a B, billion with a B, to when an ancient sea lay to the south over what is now Illinois and Iowa. Southern Wisconsin was a tropical rocky plain. To the north were mountains that had formed about 150 million years earlier due to a continental collision. Intense winds were scouring those barren mountains to the north, and heavy rains were washing sand and clay out of those highlands into streams that flowed south to this sea. And that seashore might have resembled this mud flat area now on the east coast of the United States. Those streams and the advancing sea deposited tremendous amounts of sand and fine gravel. And as the sand layers deepened, the sand grains were cemented into sandstone. Over tens of millions of years, the sandstone layers reached depths of up 4,000 feet in parts of southern Wisconsin. And this part of the state was a rolling sandstone plain. And this included the Baraboo Hills, where Devil's Lake is located. Well, then around 1.6 billion years ago, much of this buried sandstone in southern Wisconsin was converted to a much harder rock called quartzite, shown here in this old quarry at Abelman's Gorge in the Baraboo Hills north of Devil's Lake. The primitive North American continent collided with a smaller continent to the south, and the collision zone included the Baraboo Hills. Over tens of millions of years, those ancient sandstone layers were churned and deformed by heat and pressure and forged into the hard rock quartzite. It's purplish or reddish, as you can see in this exposure here. And this is because of the presence of iron in this rock. And this uniquely colored type of quartzite is actually called Baraboo quartzite, no matter where you are in the world, because of the fact that it was first found here. During the mountain building, underlying masses of this and other kinds of rock were heaved to the surface, and the end result was a low mountain range that geologists call the Baraboo Mountains. It stretched from southern Wisconsin to the west, possibly as far as the Dakotas. Well, as the mountain building in southern Wisconsin came to an end and the Precambrian seas receded, the steady forces of erosion went to work, and over the next 500 million years, leveled the land once again to a rolling, rocky desert plain, like this one in Nevada. However, in south central Wisconsin, the more stubborn quartzite peaks of the Baraboo Hills resisted this erosion and might have looked something like these rock outcroppings in this photo. At the beginning of Cambrian time, after much of the sand had been carried away by erosion, the Baraboo Hills stood about twice as high as they do today. These cliffs today are on the south bluff at Devil's Lake, and they're about 500 feet high. So those earlier cliffs were something like 1,000 feet above the surrounding plain, twice as high as these cliffs. Well, then came the Cambrian period, about 545 million years ago, and another shallow sea invaded the area. And in that sea, the Baraboo Hills stood as rocky islands. This photo is from the South Pacific, but those islands might have looked something like this. Now, remember, we were still close to the equator, so there were frequent tropical storms that battered these islands. And this resulted in a formation of layers of rock called conglomerate, made of stones and boulders cemented within sandstone. Now, hiking on the East Bluff Trail at Devil's Lake, you can see this excellent example of conglomerate. And note the rounded boulders and stones that permeate this wall. Here's one here, here. They're all through here. You can see these rounded stones kind of cemented into sandstone. And these vary in size from, say, softball size to beach ball size. My trail guide in the book describes this wall of conglomerate as evidence of an ancient cliffside on an island in the Cambrian Sea. These rounded boulders and stones started out as ragged chunks of rock torn from the ancient cliff sides by the powerful waves that lashed the shore, dropped into the surf, and then rounded by centuries of wave action. Later, they were buried and compressed into this conglomerate that you see. So these ancient seas advanced and retreated in Wisconsin for another 200 million years or so, leaving more layers of sandstone and conglomerate, along with another type of sedimentary rock made of the remains of undersea plants and animals. Now, this is a diorama in the Milwaukee Public Museum. If you get a chance to see it, go. I highly recommend it. It shows a coral reef that grew in a warm, shallow sea in the Milwaukee area around 400 million years ago. One of the earliest coral reefs on the planet, some geologists believe. It was teeming with life, the wastes and remains of which were converted to limestone, which later, by chemical conversion, was converted to dolomite, which is a harder, more erosion-resistant cousin to limestone. And sandstone, conglomerate, and dolomite once covered almost all of Wisconsin, including the Baraboo Hills. When the ancient seas finally retreated for the last time, wind and flowing water went to work, and over hundreds of millions of years carried away much of this sedimentary rock covering. Once again, the hard quartzite bluffs at Devil's Lake held firm, standing up to that erosion. In the Devil's Lake area, some of the eroding streams must have been fast flowing and powerful enough to actually drill holes in this very hard quartzite. See these pot-shaped depressions in this photo. There, smooth, rounded out pothole type formations. They were formed by water. In a fast flowing stream, an eddy or a small whirlpool can capture gravel and rocks and whirl them against the bedrock for decades or centuries. And this action can carve a pothole into even the hardest types of rock. And these potholes are located near the top of this bluff here, at least 500 feet up. So they must have been formed when the stream bed was at that level, long before the sandstone was washed out of the gorge. By about 2.5 million years ago, after hundreds of millions of years, those ancient rivers had carved the 800-foot deep gorge that would later hold Devil's Lake. Well, then, 2.5 million years ago came the glaciers. There were several glaciers during that period of the Ice Age. Some geologists think that there were as many as 15 major ice sheets that crept down out of Canada. The most recent one is called the Wisconsin Glaciation, because our state contains some of the best examples in the world of how a glacier can affect the landscape. And this one entered the state about 30,000 years ago. Note that it had 6 lobes, or major parts, flowing down. It was the Green Bay lobe here that flowed closest to Devil's Lake State Park. It was flowing generally south, as you can see, but it also pushed east, and it pushed west. And at Devil's Lake, which is right about here, it pushed ice into the gorge from the east about 19,000 years ago. Here's a closer look. On this topographical map, as you can see, the lake is on the left here. And these highlands east of the lake, occupying the center of this map, and to the right, the glacial ice crept in from the east, but it couldn't quite get over these highlands. And so these areas remained free of glacial ice. However, north and south of the highland, the glacier kept pushing to the west, and it stopped in 2 places, here and here. And it blocked the gorge at those points, plugged up the gorge. So Devil's Lake State Park is partly glaciated and partly not glaciated, which is one reason geologists are so interested in it. Now, as it moved along, the glacier pulverized and plowed away soft rock like sandstone, but it had a different effect on the quartzite hills, more like that of a pickaxe than of a bulldozer. Even in glacial times, water would flow during those short summer months into the cracks and crevices in rock. And when it froze during the long, cold winter months, it would expand and widen and widen the cracks and eventually pry rock pieces apart. And over the centuries, this freeze-thaw cycle with its pickaxe effect literally sculpted rock features such as the balanced rock shown here and the Devil's Doorway that we saw earlier. Blocks of quartzite from all around these formations must have been fractured and pried apart, and some were knocked down by other pieces of quartzite falling from above. And this process also created the talus slopes, those huge piles of fractured quartzite that lie along the bases of some of the cliffs up at Devil's Lake. On the south bluff, you can cross this talus field on 3 fairly challenging trails. Now, glaciers carry huge amounts of sand, gravel, and boulders, and as the ice melts, much of the material gets dropped at the front edge of the glacier in the form of a broad, deep ridge or zone called a moraine. Here's one in Alaska. See, here's the moraine here, this huge pile of glacial debris as the glacier fades back here to the right in this photo. At Devil's Lake, the glacier left 2 high moraines spanning the gorge at either end of the lake. This is the moraine that spans the north end of the lake, in the North Beach there, which you may very well be familiar with, the old pavilion that's been there for a long time. And then the park's nature center is near the top of this ridge. Oops. Oh, and this is the South Moraine. South end of the lake, it rises away from the South Beach area. It's that saddle of land that lies between the 2 bluffs. So at this point, let's take, just for fun, we'll finish this story at Devil's Lake in a minute, but let's take a little side trip to the Delavan area and see some of these glacial features closer to home for some of you. This map shows the glacial features of southern Walworth County. As you can see, here's Delavan here. And the 3 lakes, Delavan Lake, Lake Como, Lake Geneva. And here's the town of Walworth down here. All of the green that surrounds Delavan Lake here represents glacial deposits, the blanket of sand and gravel dropped by the glacier as it melted away. The pink areas here are called stream deposits. They represent stream deposits. The sand and gravel dropped by meltwaters flowing away from the glacier as it shrank away to the northeast. Let's go a little deeper, all the way down to bedrock. This is a bedrock map of the area showing what kinds of rock underlie the glacial deposits, which are anywhere from about 30 feet to more than 800 feet deep in this part of the county, and down to bedrock. The different colors in this map here show different ages of bedrock. Starting with the oldest here on the left, the darker blue. This is a type of rock called Ordovician dolomite, made of the wastes and remains of sea creatures laid down and converted to stone sometime before 450 million years ago. And the lighter blue to the east of Delavan Lake here is a little bit younger rock. It was deposited a few million years later. And then the green islands here are younger still. They're a type of dolomite deposited during the Silurian period, which directly followed the Ordovician period. All of the rock up in Door County on those cliffs is Silurian dolomite. And of course, the lakes, they weren't here when the bedrock was formed, but they're shown in this map just for reference. This map shows a little more detail in the post-glacial landscape. But first, let's take another look at the big picture of the Wisconsin glaciation, where we fit in there. Delavan sits right here at the edge of the Lake Michigan lobe. Now, the Lake Michigan lobe was an enormous lobe that spread all the way across the Lake Michigan basin and way down into Illinois. And this northernmost little sublobe is called the Delavan lobe. And Delavan area was lying right under the edge of that, the Delavan sublobe. And that sublobe left this moraine that you can see very faintly here, this area here. This is the area where the sublobe dropped its load of sand, gravel, and boulders on a low ridge-like formation that separates this area to the northeast from this southwest corner of Walworth County. And you probably recognize this is Highway 14 running right along that line. Here's Walworth again, the town, and here's the town of Darien. The glacier and later its meltwaters flowed from northeast to southwest, just like that. And the lakes, Delavan, Como, and Geneva were at least partly formed by flowing meltwater from the retreating glacier, probably massive flows of meltwater that bored out these long, narrow basins for these lakes. I believe that the streams that created these lake basins may have been subglacial streams. That is, they were flowing under the shrinking ice mass and gushing out from under it, at the margin here, probably here and here. Such subglacial streams were so pressurized by the enormous weight of the ice, and thus so powerful that they scrubbed away soil and rock and carved long channels called tunnel channels, perpendicular to the margin of the glacier. And here's a tunnel channel right here, probably would go flow out like that. Now these three lakes, Delavan, Como, and Geneva, are all long and narrow, and they lie roughly parallel to each other, and they lie in the direction of the flow of the glacier, northeast to southwest, and they lie perpendicular to the glacial margins. So all of this adds up to evidence that the lakes are sitting in old tunnel channels. So that's the glacial story for the Delavan area. Let's now go back up to Devil's Lake and finish up that story. The last of the glacial drama occurred about 10,000 years ago. The glacial meltwaters had drained away, leaving this jewel of a lake today at the heart of Devil's Lake State Park. The earliest native, the Devil's Lake story in my book describes how people have used the lake from the earliest Native Americans to today's visitors. And I particularly enjoyed finding out that Native people regarded the lake as a sacred place. And over the years, they gave it several different names, including Spirit Lake, Mystery Lake, Holy Lake, and my favorite, Lake of the Red Mountain Shadows. For those people, this was a place for hunting and fishing, and it was also a place for wonder and worship of the spirits. I learned some of this from a book called Song of Place, A Natural History of the Baraboo Hills, written by veteran naturalist Kenneth Lange, who worked at Devil's Lake State Park for 30 years. I will leave you with one more reading from my Devil's Lake story. It ends with a quotation from Ken Lange, and I really like his quotation because it sums up what I've wanted to gain and to share with you from my exploration of the parks. But the reading begins with my own writing as follows. Devil's Lake receives 1.5 million visitors a year on average. They hike upon 1.7 billion-year-old quartzite bluffs. They sail, swim, and dive in the 16,000-year-old lake. They camp on the moraines where ancient walls of ice once stood. Rock climbers have found 2,000 or more roots among the cracks and crags of its hard rock walls. Students of all ages and their teachers arrive by the busloads, and scientists from all over the world have probed its glades and forests for decades. For many, though, it is the stunning awareness of a sense of place that this park brings. In so many spots along its trails, you cannot help but stop and gaze and breathe and wonder. Lange said it well in a description of one morning at the park, written into the epilogue of his book. He wrote, I recall a dawn at Devil's Lake when the air was so calm and bathed in such an orange glow that it seemed as if some great mystery was to unfold. Such magic moments enrich one's life beyond measure. They represent the reward of staying in one place and keeping watch. I like that quote. And that's the Devil's Lake story. I thank you for your attention. Thank you for listening. I'd love to hear any questions or comments that you may have to offer. One more slide. This is how to contact me in case you wish to get a signed copy of the book from me or to reach me for any other reason. So if you have questions, feel free to let us know. Otherwise, thank you very much.
Thank you, Scott. As someone who is a baby hiker, I'm not ever sure I'm going to see these things, but it was really fun seeing the pictures and learning about the history. So thank you so much.
Oh, even if you're a baby hiker, you can get up there. It's easy to get up there. It's easy. It's a great place to go.
So now is your chance to speak with Scott and ask any of your hiking questions or any other questions about parks that Scott may have seen in Wisconsin. Feel free to put your questions in chat or just turn your mic on and go ahead and ask your question. We're pretty informal here. You did have one comment in the chat window, Scott. I don't know if you can see it. We have a question too. So Anita O'Brien said, thank you so much for bringing Devil's Lake to life.
Oh, good.
And,
Thank you, Anita.
And we have another question from Joey Hoover Simon. Do you have recommendations for getting kids started exploring the geology of the state parks?
Oh, there are a number of really great facilities at state parks that they're designed for children to look to, to make the geology and the natural history exciting for children. And Devil's Lake is one with a great nature center. Governor Dodge State Park in Dodgeville has such a nature center. You think, Kettle Moraine State Forest, not that far north of the Delavan area, is fabulous learning facilities and good. All of these places have good variety of trails with, some that are a little bit more challenging and some trails that are easy and more or less designed for families and children. Many of the state parks, all of them covered in my book, most of them have good nature centers where you can learn. And then websites, if you kind of go on the websites too, for the parks, you can find out some basic information.
Scott, do you know, I know the national parks do like junior park ranger patches. Do the Wisconsin state parks do something like that too?
I'm not that I know of. My wife is nodding her head, so she may know of the DNR. Gail says the DNR has some sort of children's program, explorer type program. So
okay,
check that out on the DNR sites.
Okay, and thank you. We have another question. Are there any basic tools, equipment, gear that you would recommend?
Really good, sturdy hiking boots or shoes are the most important thing to take along. Tennis shoes, that's what most people wear, and on a lot of trails that's fine. But if you're going to be hiking up over rocks, a lot of trails have rocks and roots, and it's really important to have good ankle support, especially if you're a little older. And no matter what age you are, really, hiking boots are the most important thing. Lots of people like to carry a hiking stick too, to kind of catch themselves as they start tripping. Some of these trails are just a little on the rough side. They're not impossible to pass over, but they're rugged. They have some roots sticking up. They have rocks sticking up. And then in some parks, for example, Mirror Lake State Park, close to Devil's Lake, is just all flat, easy trails. So the parks vary quite a bit, but I'd say hiking boots, maybe a hiking stick, nice little lunch in your backpack, trail map, and I think that's probably it. Sunscreen if you're going out on a summer day, a good hat to keep the sun off your face.
Water.
And water. Gail reminded me water. Don't forget to
Very
carry water.
important. Okay, we have another question. Thank you. What is the theory as to how the iron came into the Baraboo Hills? Does much remain there?
I believe that the story as I understand it, there was an ancient sea, one of the earlier, really, really old seas, about 2 point some million years old. That was I'm sorry, I can't remember if it's billion or million. There was a time when the atmosphere changed and oxygen began to become a bigger part of the atmospheric makeup, and that's what caused iron to precipitate out of some rocks and some rocks, I guess it would be minerals. And that iron got into the water, and then it settled and became part of the sand. And this is primarily, most of this is up in the Lake Superior Basin and points northwest of there. All of the Lake Superior Basin and a huge area to the north was covered with this iron sand. And that's why you have the iron ranges up there now in Minnesota and in Wisconsin. When the glaciers came plowing down for 2.5 million years, many times, they brought tons and tons of this kind of sand, this sand that has iron in it, down into the Baraboo Hills area, and that's probably where it came. You can also find that reddish sand in areas of the Lake Superior Basin. So it was pushed down by the glaciers, huge amounts, and then eventually it was. No, I'm sorry, it wasn't pushed down by the glaciers, but it was carried by water, moving water, and then when the when the continental collision happened, the sandstone, that sand was forged into this quartzite. So it was way before the glaciers. Sorry, I got a little mixed up there. But the glaciers did bring more reddish iron sand down. But the rock, the Baraboo rock, got iron in it during that earlier period when sandstone was being metamorphosed into this really hard rock by heat and pressure.
Thank you. Another question. You mentioned that the land is now Wisconsin was once tropical. How do scientists know that?
They know it by the presence of rocks that had to have been formed in a tropical environment. For example, the coral reef, all of the Dolomite on the east side of the state, much of it was formed on coral reefs. And the only way you can have a coral reef is to have a warm, tropical, shallow, clear seaside, tropical coastal area. That, and then there's lots of other evidence of plate tectonics that shows how the continental plates have shifted around. And it's just been a huge, long process of putting together millions of pieces of data by thousands of geologists. It's really quite impressive how they worked together over the decades to put all this data together to show how these plates moved. And they can trace the movement of the North American plate, as with any other plate, by the presence of rock, the presence of rock there, knowing where it had to have been formed, as well as by more complicated processes involving radioactive decay of certain types of minerals. And I can't explain that very well at this point. I think that's too long a story for the time we have. And I don't completely understand that part of it myself, but they have different tools, and they have lots and lots of data.
Thank you for that. I bet we have books in the library collection that would go into quite a bit of depth on that
Plate tectonics, yeah.
Yeah. I think I remember that from a geology class. Okay, so here's a question from Mike. He says, Scott, is there a way to get an annual park pass for Wisconsin? We went to Devil's Lake last year and I think we paid $16 for a day pass, but someone said that we could get an annual park pass for all 16 parks.
Oh,
Can
yeah.
you tell me where to get the annual pass?
Well, the annual pass can be gotten on the DNR site anytime you want. And we have 49 state parks, and and all the state forests and all the state recreation areas. If you add up the state recreation areas, the state forests and the state parks, the number's over 100. And so, yeah, an annual pass will get you into any and all of those, plus some county parks. It's kind of amazing for the price that you pay. And you can get it on the DNR site, DNR org. I'm not sure. I don't know. I'm sorry.
So Mike,
Google Wisconsin State Park Pass Annual. I'm sure you'd find it.
yep, that's exactly what I just did. And
Mhm.
there's a DNR site called State Trail Pass.
There you go.
So it looks like it has resident and
Mhm.
all of that in there.
And a good deal for seniors.
Oh, yeah. Okay. Any other questions, anyone?
Those are great questions. Thank you.
They're great questions. So just so you know, the library does own a copy of Scott's book, and you can always contact Scott himself to gain a signed copy as well. And we hope to have Scott back, hopefully maybe in the fall, to talk about fall landscapes and trails you can take then. So thank you, everyone. You have my email if you have any future questions. I can get a hold of Scott, or you have his email here as well. You have several thank yous in the chat window, Scott.
Good.
So thank you on behalf of Aram Public Library and our attendees. We really appreciate your time tonight. And
My pleasure. My
thank you
pleasure.
so much. Okay, and thank you, everyone. And keep an eye on future programs. At the end of the month, we have an Ice Age Trail author speaking on the Ice Age Trail and her adventures there, and how nature can bring Zen to your life. So thank you, everyone. Stay healthy and goodbye.
Bye.
And Scott, thank you.
You're welcome.
I'm going to stop the recording.